Hello everyone. In this video I am going to demonstrate PT100 based temperature measurement using Wheatstone bridge. So this is the LCD display of my project. So as you can see here, the LCD display is showing the physical counts. Here 265 is the number of counts of the analog channel and this is the temperature of my room. So this is the Arduino Uno. As you can see, this is the Arduino Uno. And I am using analog channel A0 of the Arduino Uno to calculate and display the final temperature on the display. So the circuit consists of a Wheatstone bridge and operational amplifiers. So this is the Wheatstone bridge. This part of the circuit is the Wheatstone bridge. As you can see, arms of the Wheatstone bridge. This is one arm. This is another arm. Here under the wires there is one arm. And the third arm and the fourth arm is the PT100 temperature resistance. So I am going to show you the PT100. So this is the PT100 temperature resistance. Okay, this is the RTD. You can see resistance temperature detector PT100 type RTD this is, and this is wired with this wire to the bridge. As you can see, it is wired to the bridge. So as you can see here, I am going to show the bridge here. So this is the Wheatstone bridge. Okay, so on the Wheatstone bridge the power supply is plus 5 volts and the other terminal is grounded to ground. So there are 4 arms of the Wheatstone bridge. So these 3 are the fixed arms, fixed. So all the three fixed arms are of 100 ohms and the variable arm is PT100. This is the variable arm. It will measure the temperature. The resistance will change in terms of temperature and there will be unbalance in the bridge. The unbalance will create a voltage difference across these 2 arms and that will be processed by the operational amplifier circuits. So as you can see here, I am using 100 ohm 1 watt resistance here. I am using this resistance because the bridge voltage is plus 5 volts. So if I put 5 volts, this 100 ohm resistances, there is a chance of heat. These resistances will heat up and this will cause errors in the bridge. So that's why I want to reduce this voltage 5 volts to 2.5 volts. That's why I am using 100 ohms 1 watt resistance. So this is the 100 ohms 1 watt resistance. You can see this is the 100 ohms 1 watt resistance. So this resistance is used to drop the voltage. This is the 7805 regulator, the plus 5 volts regulator from 12 volts. So the output of the regulator I am dropping with this resistance 100 ohms and I am feeding to the bridge. So as you can see here, when I am feeding to the bridge, now the voltage here is 2.5 volts, here is 0. So whenever there is a temperature change, whenever I am heating or cooling this PT100, the bridge unbalance will occur and the voltage will be fed to the operational amplifier. So this operational amplifier is configured in differential amplifier mode. So this is the differential amplifier mode. The gain of this differential amplifier is 10 because 10k divided by 1k, 10 kilo ohm by 1 kilo ohm is 10. So whatever voltage I am getting, whatever unbalance in the bridge is happening is fed here between these two terminals and it will be multiplied. The voltage will be multiplied by 10. Okay, so the voltage will be multiplied by 10. So this is the differential amplifier configuration of operational amplifier. The output of this operational amplifier we cannot feed directly to the Arduino Uno. This is because the Arduino Uno has different input impedance and this device has a different output impedance. So that these two impedances, they don't match. So if I connect them directly, there may be a chance of overloading. That's why I want to match this impedance with this impedance. That's why I am using a unity gain buffer. This is a buffer circuit. This buffer circuit will not allow this circuit to be loaded due to Arduino Uno. So basically this circuit is a buffer and it is isolating this circuit and this circuit. So this is the unity gain buffer. The gain is 1. So as a result, now the total gain of the operational amplifier will be 10 into 1 is 10. So whatever voltage I am getting here will be multiplied by 10 and I will be getting it here. So this is the theory of operation of the circuit. Now I am going to show you. This is the circuit. So here is the LM324 op-amp and these resistances are in the differential amplifier and the unity gain buffer. There are 4 op amps in this op amp. This is the quad op amp LM324. I am using only 2 of them and 2 are spare. So the output of the op amp is shown in the multimeter. As you can see here, this is the output of the 2 op amps, 1.125 volts DC. It is reading corresponding is 16 degrees centigrade. As you can see here, this is the 17 degrees centigrade temperature it is reading. So this is the corresponding voltage. Okay. So now if I touch the sensor, I am going to touch the PT100. It will read my body temperature. I am holding the PT100 now. You can see the temperature is increasing. You can see it is going to detect my body temperature. It is increasing slowly. It is increasing slowly. So here you can see the voltage also will increase. Similarly, the voltage here also will increase. So now I am going to cool the sensor and I am going to see the response when I put the sensor in ice. So I am bringing ice. I am pausing the video for a while. So as you can see here, this is my ice block and this is my PT100. So I am going to put it over the ice. Let us see the reading. You can see the sensor is cooling. You can see the voltage also. The voltage is dropping. So now I have removed the sensor from the ice. So here you can see the temperature is increasing. Okay, so the thermometer is behaving. Thermometer is responding properly. Now I am going to show the software. As you can see on the software, I am using map function. I am using analog channel 0 and I am using the scaling. This 200 and 1023, 0 to 300 degrees centigrade is the range of my device. Okay, so there is an offset. So this is the offset count. So this is how the software looks like. This is the LCD display commands. Okay, so this is how the software looks like. Now I am going to heat up the sensor. So as you can see, this is the flame. So I am putting the sensor on the flame. The sensor is in the flame. You can see here the temperature rise is coming. So I need to show the voltage. So here, as you can see, the voltage is now increasing. You can see when I am heating the sensor, you can see the count is jumping. You can see the voltage also is increasing. You can see the voltage also is increasing. You can see the count is also jumping. Now I have removed it. The sensor is now away. It is cooling. Gradually you can see it is cooling. And the voltage also is decreasing here. You can see the voltage here is also decreasing. You can see the device is cooling now. So I am going to heat the sensor again. You can see the temperature is increasing. The voltage here is also increasing. It is deflecting here. You can see it is deflecting here. Now I have stopped heating. So it is now cooling back. you can see it is now cooling back. So this is how the circuit is working. You can see the temperature is now coming down, it is cooling back. Okay, so as you can see here, this is the circuit diagram. As you can see, this is the circuit diagram. This is a tested circuit and can be made. Thanks a lot. Thanks for watching.